Today I'm going to give you lectures on bonding mechanism in metal complexes with carbonyls as ligand. For examples, this is chromium with 6 carbonyl ligands attached to it. In the bonding mechanism with metal in metal complexes, there are two types of bondings. The first type of bonding is what we call as sigma bonding. Well, sigma bonding actually referring to a transfer of electrons from CO to metals, and it involves head-on overlapping of a sigma molecular orbitals or HOMO, which refer to highest occupied molecular orbitals of CO and D orbital of metals. Here's examples. This is a D orbital of M of the metals. Well, I took example for dx squared minus y squared orbitals, and this is sigma orbitals of CO. Okay. For sigma bonding, of course, it involves overlapping of d orbitals on M and sigma orbitals in CO. So this is the overlapping between the two orbitals which form the sigma bonding. Now, the second types of bonding refer to pi back bonding. Okay. Well, in the process of producing sigma bonding, it will increase electron density on M. Okay. Now, when M has that extra electron density, it will have the tendency to donate back its electron to CO. This back donation involves the transfer of electron from d orbitals of M to pi orbital of CO, which refer to the lowest unoccupied molecular orbitals. These sideways overlapping give rise to pi back bonding, as shown in the diagram here. We have the d orbitals, which basically different than the d orbital involved in sigma bonding. Okay, here I take example as dxy of M and overlap sideways with pi antibonding orbitals, which is the LUMO of CO. So this is the second type of bonding when CO or carbonyls attach to metal in metal complexes. Right. The implication of pi back bonding is very significant. There are two implications. One, it strengthens the M to C bond. Okay, it strengthens the M to C bond as a so-called double bond is formed between the M to C bond. And second implication is it weakens the CO bond due to the changing of the triple bond to double bond in CO as shown in here. Originally, CO as a free CO has a triple bond between C and O, but once it formed a complex with M with the pi back donations, it formed a double bond, a so-called double bond between M to C. One bond from the sigma bonding, and the second bond is from the pi back donations. So that's why the M to C bond becomes stronger, and the C to O bond becomes weaker. Another way of looking at weakening CO bond is where does the electron go into when being transferred from M to C. It is actually put in an anti-bonding orbital of CO, the pi star. Does that destabilize the entire structure of carbonyls? So basically the presence of pi back bonding is favorable as it strengthens the M to C bond, thus stabilizing the metal complex as a whole. Thank you.